Hi Year 11. The purpose of this video is to give you some last minute advice for paper 2 in 2019, which is tomorrow. So hopefully you can listen to this for the next probably 2 parts of this video, maybe about 40 minutes and 20 minutes per part, and get some hints and tips. I use this with my class today, this little revision booklet. I'll dip in and out of it, but I'll also do some extra examples if I can. But I got a feeling you'll use quite a lot of the front page in tomorrow's exam. Okay, so the first thing in the formula page is the trapezium, the area of a trapezium. And we might use that, particularly at higher T, we might use that for the Trapezium Rule to find the area under a graph. It'd be quite late on, I would say, in the paper if it is. So let me quickly find one of those, something like this. Okay, the velocity time graph shows the first 60 seconds of a journey. Part A says estimate the acceleration where t equals 20, which is there, right, where t is 20 there. Now the velocity at that time is 30, but that's not what it's asking for. It's asking for the acceleration. The acceleration you'd have to draw, and I'm kind of a lot of this is going to be very rushed, okay? But I'm drawing a tangent to the curve at that point that just touches the curve. And I need to find basically the gradient. The acceleration is the same as the gradient at the time t equals 20. So the gradient of that line. So rise over run. So I'm going to kind of draw myself a nice triangle using 2 nice points. And I think basically there I've gone over 10 and up 9, I suppose. Okay, so for me, it'll be different depending on the tangent. It's the gradient is rise over run, 9 over 10, so 0.9 meters per second squared. Okay, I wouldn't worry about that too much. What I was talking about was the trapezium rule, which is this part B. I'm going to do my workings up here though. I got to work at the area under the graph using the trapezium rule, but what I'm doing is just splitting it up. Okay, it says here, it talks about ordinates. Again, I'm back and forth. T equals 0, t equals 10. That's just basically where you split the graph. So a line at each one of those ordinates. And what you basically end up with is a little triangle here. Particularly if you connect that with a straight line, you've got a triangle. Then if you connect there to there with a straight line, you're basically turning that into a trapezium. And there to there, and there to there, and there to there, and there to there. And okay, random one. All right, you've got to start here and work your way along. But if you call them A, B, C, D, E, if I just focus on E, all right, trapezium E, the height of that line is 32. The height of that line is 39, potentially, is it? Yeah, and 39, that'll do. If I wanted to work out the area of that trapezium, it would be half. 32 plus 39, so A add B, half it, and then times the height. So the height is between 40 and 50, so that's a height there of 10, so times 10. 39, that's 71, half of 71, 30.5 times 10, 305. Okay, you use a calculator though. Alright, yeah, cool. That's the first thing. The trapezium rule, but then it tells us how to work at the volume of something by finding the area of the cross section or the front, and then times the, well, they use the word length or depth. You might get a question on spheres and cones, surface area or volume. I'm not going to do anything on that now, but if you do get one, just remember they're there and do your best and use them. I think it's unlikely because you had a sphere question, nasty sphere question in paper 1. Now, the other things on this front page, you will not have, or at least I would be very, very shocked if you have an AER question, a topic far more likely in numeracy than in a maths paper. But these two, we've definitely got to look at, okay? So let's start with some sine and cosine. So we're at the back of the paper. Okay, it'd be quite near the end, these will be, and you're looking for triangles that aren't right angle triangles. Now, the things I'd be looking for, let's get some paper. I'm looking for a pair. By a pair, I mean an angle opposite a side. That's a pair, okay? If you can find that, the chances are they'll be using the sine rule, okay? And they'll probably then give you another side, potentially, and ask you for this angle. Or give you that angle, 40, and ask for this side. either way. You're using then that second pair, and that's the sine rule. Sine A over A equals sine B over little b. Or the reverse, that divided by that equals that divided by that, if you're finding the side rather than the angle. The other thing you might be looking for is a trio of things. Okay, what I mean by that is in angle, but instead of knowing opposite it, instead of knowing its pair, knowing the other two sides, 12 and 14 say, so that kind of triplet of things there. And you can use that triplet to find this side using the cosine rule. A squared equals b squared plus c squared minus 2bc cos A. Or you can find the area of this triangle using half AB sine C. Right, let's get back to this one. So what do I notice with this one? Straight away I notice I haven't got the triplet, but what I do have is that pair, okay? And I'm asked in this question to find the size of angle XYZ, which is this one. So I'm then going to use that pair there, okay? And the sine rule says that the sine of this angle, I'll just call it theta for now, divided by 23.8 opposite it, is the same, is equal to the sine of that angle divided by 38.9 opposite it. How would I then go on and work this out? Okay, this is dividing by 23.8. I think I'd pop that up there and times all that by 23.8. Now, by the time I put this in the calculator, we're going to be there all day. However, whatever this works out to be in the calculator, okay, we're not quite finished, because theta, I'd need to take the sine over as sine minus 1 of that and get, that'll be my final answer, okay? So that's the kind of thing you're looking, if you're going to use the sine rule, you're looking for that a pair, an angle opposite a side. Here, I immediately spot that I haven't got a pair, but I have got this triplet. Now, this question is about working out the area of the combined area, so I need the area of this and the area of this. Well, I've got enough information for the area here, okay? The area of this would be half, not minus half, equals half, times A times B times sine C. So basically that one times the sine of the angle between them, and you could work that out. This one, the area would be half times 9.7 times, don't know that for a minute, put an X in I suppose, don't know it, times sine 48. So this would be very, very simple if I'd known that side, okay, because I would have just done two area calculations and added them together. However, how can I find that side? Well, like I said just now, it's the same triplet there is used to work out this using the cosine rule. So using the cosine rule, this becomes little a, right? This is big A, and these are little b and little c, and the cosine rule, as we've said, is a squared equals, so a squared equals b squared, 8.2 squared, plus c squared, 7.6 squared, minus 2 times b, 8.2, times c, 7.6, times the cosine or cos of the angle, 42. So it's the same triplet, but used this way. Again, put that in your calculator, you'll get an answer, but remember that's a squared, so you'll need to square root your answer to that. That's that side, use that in there, boom, you're away to go. Okay. Expect that quite near the back of the paper, alright? Look for the pairs and the triplets and try and use the correct formula. If you want any more help with that, okay, booklet D, video 2. We'll talk you through more of those. Maybe pause this one and get into that one, or after this is finished, try that. The other thing that I think is a certainty for tomorrow, again near the back, would be the quadratic equation. What tends to happen here is you've got a quadratic like something x squared plus something x plus something equals 0, okay? But the giveaway, they don't tend to say use the quadratic equation. They tend to say solve this quadratic to 2 decimal places. So if you can see a quadratic and it says solve to 2 decimal places, this is what we're going to use. We're not going to factorize, we're going to use this formula here. Now, there might be a part A, a la this one, where you have to prove that this is the same as this, okay? I'm not actually going to do that right now, but just to give you an idea, to kind of you merge these two into one by doing 5 times that and 3 times that, and then on the bottom, that times that, so you kind of make a single fraction. Then whatever's on the bottom, which is this times this, all goes up as a times. And if you did a bit of moving around, you'd get that. Look, that's irrelevant to me now. The part B is what I'm interested in, where it then says, okay, now that you've proved this is this quadratic, go ahead and solve this, solve the quadratic to 2 decimal places, and that's my giveaway, that I'm using the quadratic formula. Now, the one I'm going to do, because it's a little bit more difficult, I added an extra one. I'm going to use the formula to do this one here on a bit of paper, okay? So let me copy down the one I'm wanting. So 5x squared minus 10x plus 3 equals 0. Got to be equal to 0. If you had anything over this side, it has to come over onto this side. So if there's a number there, come over and take it away from the 3. Or if there's an x's, take it away from the x's, and so on. There's the clue though. 2 decimal places. Solve 2 decimal places. Right, let's do it. Let's do it. In this case, the number before the x squared, which is a, is 5. The number before the x, which is b, is minus 10. Huge. Don't miss the minus, or the whole thing has gone to pot. C is plus 3. Not 3, okay? The quadratic formula says x equals minus b, but b is minus 10. So minus 10. Plus or minus the square root of b squared. So that's minus 10 squared. You can see how it's more awkward when b is negative, okay? Minus 4 times a, which is 5, times c, which is 3. All divided by 2a, and again a is 5. Right. At that point, I think I'd concentrate in here and I'd work this out. So into my calculator, my Casio, I'll put minus 10 squared, okay, minus 4 times 5 times 3. Now, I'll quickly do that in my head, but if you use your calculator, you should find that that gives you 40. Also, the other thing I'm noticing here is the minus, because b is negative, so minus 10 is the same as 10, okay? Plus or minus the square root of 40 divided by 2 times 5, which is also 10. Split them up. Answer number 1, x equals 10 plus that divided by 10. Shove it in your calculator. Answer number 2, x equals 10. Oh, you can't even see that. Sorry. X equals 10 minus, I told you this would be rushed, that divided by 10. Bang them in your calculator and you'll get 2 answers for x. Okay, but before you start, write the formula from the front. Write down what A, B and C are. A, B, C. Put them in brackets, and then just hope your calculator work is up to scratch. So that's a kind of guide through the front page, but I would say a lot of these will be later on. The trapezium rule question, the spheres and cones, if they're there, I doubt it. The sine and cosine rule and area using half A, B, sine C, definitely there. The quadratic equation, definitely there. Okay. The other things that are quite certain, I would say, in here, and that we're going to get through in this first part of the video then, would be things like trial and improvement. Okay. Just be careful. Make sure it says use trial and improvement. It'll, you know, specifically tell you this is what we want you to do. Guess and improve your answer. If it's between 2 and 3, for example, all right, the answer is between 2 and 3. Try 2.5. Always start in the middle. 2.5. Cool. Right, set it out like this. What am I doing? I'm trying x is 2.5. So instead of x, I'll put 2.5. Boom. X cubed, so 2.5 cubed. Minus 6x, but instead of x, in brackets, 2.5. I like when I substitute things in, putting them in brackets. And then minus 4. Do not put equal 0, because this will not equal 0. Whatever this is equal to will be either bigger than 0 or less than 0. And you then need to write, okay, this answer is too big or too small, depending what it is. Okay, if it's too small, try something bigger like 2.6 or 2.7. If it's too big, try something less like 2.3 or 2.2, and keep going. And what you'll find in the end, right, and I don't know the answer to this, is that you'll have one answer that's too high, and I think in this case we found that 2.7 is too small and 2.8 is too big. I think, or I can't quite remember, but I'm not going to do it now. Once you've got one too big and one too small, you check the middle. So in this case, you'll check 2.75 and put that in there and there. If the check is too big, it suggests that your answer is less than 2.75, so you state the answer 2.7. If the check is too small, it gives an answer less than 0, then it suggests that the answer is bigger than 2.75, so you'll say that the answer is 2.8. Now, the last few minutes here, okay, what I've tried to do is give you things that I'm pretty confident coming up. The sine, the cosine rule, the quadratic equation, the trial and improvement. They are 3 questions I would expect. You're also certain, I would say, to get Pythagoras' theorem, right? Don't mistake it for the sine rule or cosine rule. It's much earlier in the booklet. I don't know, first half of the paper, okay? Might be even earlier than that, could be question 3 or 4. Quite simple, square, square. And in this case, if you're finding the small side, it's square, square, subtract square root, okay? But if I knew that and I was looking to find the hypotenuse, the big side, I tend to square this, and then add them together and square root. So the only thing that can go wrong, make sure you add to find the hypotenuse, or you take away to find a smaller side. So another certainty for tomorrow, Pythagoras. Oh, be careful, I suppose. It might say something, it might be hidden, like a right angle triangle hidden in a rectangle. So it might say, a TV is 40 centimeters long and 20 centimeters high. Find the length of the diagonal. Well, the diagonal is that. Alright, well, that might be easier if I put the 40 and 20 there. So, okay, the diagonal of a square or the diagonal of a rectangle is basically the hypotenuse of a right angle triangle. So square, square, add square root. A few questions after trigonometry, you will get a few questions after Pythagoras, apologies, you'll get a trigonometry question. Again, you should be looking for these right angle triangles. Get them out of the way if you went early on in the paper. Find the right angle triangles around halfway, maybe just before halfway. It should probably be Pythagoras first, and then trigonometry will be near the same place, maybe a couple of questions later. Okay, I will do these to make sure you're happy. Part A says calculate the length of AD. To find that, I'm using this triangle. This is the angle I know, so you're the opposite, you're the hypotenuse, you're the adjacent. We'll do it up here. So, Toa. Right. Again, just remind yourself at this point, I guess, why am I using trigonometry, not Pythagoras? Pythagoras is when you know 2 sides and you want to find the third, or you know those 2 and you want to find the third. Trigonometry is the one with the angles. If you know the angle, or in this case we're going on to find this angle. So if there's an angle involved, it's trigonometry. If there's not, it's Pythagoras. Okay. Here, what do I know? I know the hypotenuse. I know the angle is 56. I got 2 things left. Which one do I want to know? Well, it's AD I want to know, so I want to know the opposite, so let's get rid of that. So I'm using so, and the opposite is equal to sine 56 times the hypotenuse 16. Put it in your calculator. Okay. The second part says find angle X. I'm having to use a few things here, right? My answer to part A will tell me this. Now I'm pretty confident, if I can remember, I'm sure it's 10.3. We did it a couple of hours ago, but 10.3. If that's 10.3, then it's also 10.3 here, and you'll need to take that away from that, and therefore this little bit here is 9.7. We also know the length here is 15. Okay, we don't know the hypotenuse, but we know the opposite, and we know the adjacent. Okay, you find in the angle, knowing that the opposite is 9.7 and the adjacent is 15. Let's get a bit of paper. So I can write here. So Toa. This time I cross out SCT because I want to know the angle, not because I do know it. But I know the opposite, cross out O, and I know the adjacent, cross out A. Toa. Toa tells me that tan of the angle is equal to the opposite, 9.7, divided by the adjacent. So tan of the angle is equal to the opposite divided by the adjacent. Put that in your calculator, 0.something in. But to find the answer, remember, you got to take the tan over, so it'll be tan minus 1 of whatever that answer was. Okay. Okay, I'm probably not going to fit much more on that video, but they are absolute certainties for tomorrow. So remember those 5 or 6 questions that I've gone through, okay? The quadratic formula, solving quadratics to 2 decimal places, that's what you're looking for. The sine and the cosine rule and the area rule near the back of the paper. Trial and improvement near the front of the paper. Pythagoras near the front of the paper. Trigonometry probably about halfway, okay? The next video we will shoot through as fast as we can as many other things that I think I've got a chance of coming up tomorrow. Again, it'll be quite a quick overview of that. See you on the second video.